Hey everybody, Sean Tierney here from the Automation Blog and School, and in this episode of the Automation Podcast, I meet up with Louis Arone from Schneider Electric to get up to speed on their next generation of automation systems. Lou, thank you for coming on the Automation Podcast and taking time out of your busy day to give us this update on your products. And before we jump into your presentation, could you just tell the audience a little bit about what your position is currently?
Yeah, sure. Thanks, Sean, for also having us on. So I've been with Schneider Electric for 20 plus years, all of it in the automation and control arena. And right now, I lead our systems architect experts team, which we call SAEs here. And they're our experts on our automation products, both hardware and software.
Oh, that's excellent. And what are we going to talk about today?
Well, we'd like to talk about our next generation automation systems and a little bit of the vision of how we see the future of the factory floor.
That's awesome. Well, the audience knows I don't know much about this, so I'm going to be listening I'm going to be really focused in on while you're talking. So please take it away.
That's good. That's good. Good. So I label it, as you can see on the screen here. It's our next generation system. It's moving PLC control to the edge, and that's really a little bit about what we're going to talk about. But it's also about setting the vision of what is the next generation control system. And so first, I want to stay up for all the people that are Modicon users that are out there. Your existing control is not going away. Today, we have EcoStruxure Control Expert. And we also have a machine expert for the OEM type machines. But we've also added a new class, which is EcoStruxure Automation Expert. And that's built on the IEC 61499 standard. And we'll talk a little bit more about that later on. But it's specifically geared towards the person who's looking at the next generation system, the smart factory, embracing IIoT. And it'll become apparent of why we are going in this direction, why it has to be a little bit different than our existing systems. Let me go and put a pointer up here. So Sean, I'm gonna before I start there, let me also say that Schneider Electric, we have our IIoT architecture, and it's all about connected products, edge control, and apps and analytics. And we took all of our products and we put them in here, and this is how we connect our products, how we envision all of our products from an automation perspective, and not just automation. Our entire company fits into this IoT platform. What I'm showing you today is just about just our automation products. It fits in the end-to-end cybersecurity, which is uber important for Schneider Electric, and then it has to do with either cloud or on-premise communication as data storage. But when we look at this, we've been hearing about IoT in the world and in Industry 4.0 for many years, and we took these products and we kind of classified and put them into these classifications: products, connected products, edge control, apps and analytics. But did we really do something extremely revolutionary? And the answer is no, right? We took our products, we can connect things, and how we design and allow our products to communicate to each other is nice, but it hasn't really drastically changed what's on the factory floor. And that's really what I wanted to talk to you a little bit about today, is about the factory floor. So I have a question for you, right? Before we start and get into it, right? So you're a guy that's been involved with automation, and have you thought about what the factory floor looks like in 5-10 years? Is it different than what we have seen for the last 50 years?
It's funny you asked that, because I'm asking a lot of people that question. So I have been thinking about it, but I'm really more interested in what your vision is, because we have several people coming on to talk about that. So you get to be the first. So what are your thoughts on that?
Yeah, so it's great. So a lot of customers are in the same boat, right? They're not really sure where we're heading with the smart factory, and are very cautious. There are a few customers out there that are looking forward. Okay, what is that next technology? How are we going to change things? So let me take a look at this. First, the future is not the same, right, that we've been doing for the last 50 years. We look at technology and how it's changed, right? Especially on the factory floor, but even in our lives, everywhere in our lives, things have changed. They've become smarter. And so today we have a very hardware-centric view of the factory floor. Everything's around the hardware. Everything's tightly coupled. It's very proprietary. We don't see the future that way. We actually see the future where everything is much more open. Everything is much smarter. Everything is based around software and not exactly the hardware. And so that's what we're going to really talk about. And again, Industry 4.0, we're going to look back. And yeah, we've been talking about this for a number of years, but we'll look back in history and think about today as probably being maybe the start or the beginning, the very beginning of what Industry 4.0 really means to the industry. And again, we'll talk about that. So here's an example of a PLC system today, right? It's been this way since Modicon invented the PLCs, back in the 1960s, 1970s, and the first PLC came out. Again, central PLC, I have remote I/O that's out here. The I/O is all connected, hardwired to, some I/O module. Yeah, we have used and added Ethernet in some form. And other networks in some form. But the concept is all the same, where you have to go out, you have to pull this device, you have to grab information from this device and bring it back to a centralized PLC. That centralized PLC processes this data and then sends it back out. Again, it just that's the way we've been doing it for many, many years. There have been some advances, but not a tremendous amount of advances. But when you look at products, and this happens to be a Schneider Electric Thesis Island, it's a motor starter product. This is where we're heading. Now, this is not part of our offering today, but will be in the future. This is a motor starter. It's a bunch of motor starters ganged together. And instead of having the traditional, control wiring and the auxiliary wiring and any kind of other information you want to get, you have to add wiring to it. This is you stick an Ethernet a module right at the front. You pile these motor starters together, and the only wiring you have is the motor starter wires in the back. Very clean, very efficient. You get a ton of data, right? So you control through Ethernet. You bring back status and all kinds of advanced analytic type information that you can bring back from your motor starters. Makes for things to be very clean. Your I/O, right, or your devices out in the field are becoming smarter, right? This Thesis Island is a smarter device. You're able to do a lot of things on this thing. You even do, small control on there and reaction type stuff based on I/O. You can add I/O to it. So it's not hard to see how all these types of devices are getting smarter out in the field. The motor starter happens to be one of them. Drives is another. But if you let your mind wander, you can start to think about how instrumentation, right, and everything we connect to is going to get smarter, right? And so here's an example of where we see the future, right? So we take a typical system where everything. So again, this is not today. It could be today, but it's not today. It's maybe 5 years out. It could be 10 years out. The industry moves slowly, but in the future we see that all devices are connected via Ethernet. No need to hardwire back to a system, and maybe in the worst case, in the most extreme case, there is no I/O. Everything is connected via Ethernet. And that's probably an extreme. You probably always need some I/O to some extent. But the point is that all the devices, the main devices that are out in the field, your sensors, your process instrumentation stuff, your motor control, they're all smart, all connect to your intranet. And then so you have to ask yourself, today you have a PLC that's here, and it has to go out, pull this information, bring it back to go ahead and control a VFD. Let's say we're talking about a level in a tank. Oh, well, if everything is connected via Ethernet, then why do I have to bring all this information back to a PLC? Why can I not just have the drive speak directly with the process instrumentation? Maybe it's the level sensor, for example, or maybe some proximity sensors. And they all talk back to the drive, and the drive can control it automatically. And that's happening throughout the entire facility, where all the devices are smart and they're all talking to each other. That's a complete change to what we do today, where everything is a centralized logic inside of a PLC.
Yeah, and I just want to jump in here. I think that is the trend, right? So to
Yes.
predict the future, we could definitely see that everything is getting smarter, everything is getting networking. So originally it was your PLC or your DCS, and then everything was hardwired into it. But now that's been pushed down more and more to just like this for the podcast audience, the audio only audience, getting pushed down to the point where everything is smart and everything can talk, like the processes instrument can talk directly to your VFD, and your VFD can have an algorithm in it to control other things or look at things and change its behavior and how it controls. I mean, it's not just an encoder anymore going into the VFD. It can be all kinds of I/O, and I see where you're going with this, and it's definitely where it's going. I think, not to steal your thunder, but I think at some point there's a little pushback where somebody says, all right, now every device has its own program. This is crazy. I don't want to have to program every device on the line. It's just too much. We need some centralized programming. In certain instances, if it's a small skid system, then, it might be great to have 3 or 4 programs. But if you have hundreds of VFDs on the line, it may be too much to have 100 little programs running, and may want to coordinate that all with your PLC PAC. So I can see that being the pushback. But go ahead.
Exactly. That's actually a really, really good point. And so before I had mentioned, this separation, we're moving to a software-centric world, and we feel that in everything we do, right? Even in your home lives, everything's around software today. But certainly on the factory floor, there's a focus around software. But I had mentioned to you about the automation expert, EcoStruxure Automation Expert is a software. It is decoupled from the hardware. It's meant to by design, right? And in order to do that, you need to have let me introduce a couple of standards that have come up. One is the IEC standard, the IEC 61499. That allows us, and we'll talk a little bit more about that in a second, some advances in the way we program, right? It introduces these CAT objects in the program, and they are very valuable in the distributed control that you're talking about, that you had just mentioned. But today, in today's world, right, you have a software component of your PLC system, and it programs a PLC, and that's all it programs. But it's vendor A programs vendor A's PLC. That's it, right? But when we look into the world of the IEC 61499, and then we add on top of it this new organization called Universal Automation, right? That's a new standard that's out there, which allows everyone to program to a single standard. This allows you to decouple the PLC or the hardware, right, from the software. It allows customers to use best-in-class products on the factory floor and the software, but they're all programmed the same way, so they're all interchangeable. So for instance, right, you can program with EcoStruxure Automation Expert, which is our software that we've released last year, a year and a half ago. It is like an umbrella software. Think of it like an umbrella software. It looks over your entire facility, your entire process, and you program it just like you do today, one single application, and then you divvy out the code to all the different, whether it's a drive or a motor starter or remote I/O. You program it like you do today, except you distribute the control. From the hardware perspective, you get to use best in class. So if it adheres to the Universal Automation Standard, you can replace any of these devices. As they age, as they get older, you can replace them with best in class products. As long as it adheres to Universal Automation, you can pop out the old, pop in the new, and send down the logic to it from EcoStruxure Automation Expert.
Cool.
Does that make sense?
That makes a lot of sense.
Yeah,
it's intriguing
it's actually,
too.
It is. It's actually very intriguing. It's something that we're really excited about, as a matter of fact. So let me move a little step further. So, what is Universal Automation, right? Well, first of all, it's a third-party organization. It's an independent organization. Schneider Electric is a founding member, along with another 25, 30 different vendors and end users that are out there that share this same vision. we're looking for customers. So please, if one of your customers or if a vendor is interested in this and going down this road, go to universalautomation.org to learn more about Universal Automation, how you can become a part of it. But this is all about plug and produce solutions. So our first offering is this offering that you see here. So you have an ATV DPAC module, which runs in a drive. Again, it's a PLC module that runs inside of a drive. An M251 DPAC, which is a small, a medium performance I/O drop, you could think of it. It's a processor. The M580 DPAC, this is a high performance PLC for distributed control. And it also runs on a soft DPAC. And so you don't need to have a traditional PLC processor. This will run on a blade server. It doesn't have to be Schneider Electric hardware. It could run on any PC. But before we go into this, I wanted to stress a little bit of the benefits. Right, there are benefits to both the end user and the OEM. So let's take the OEM for instance. The OEM is burdened today with if he's an OEM and he wants to serve a marketplace for whatever, he has to have different versions of his machine, right? He has to have it for vendor A, vendor B, vendor C, because that's what the customer in the marketplace is asking for. And that's tough for an OEM, right? Because they have to have someone on staff to not only design, but to support 3 different versions, 4 different versions of their machine for PLC. They have to have software, expertise, and then to be able to service it in the field. So in a lot of cases, you can maybe they upcharge a customer to do it in a certain vendor's PLC, but it's not really their go-to PLC, for example. Think about the support afterwards. They may do it once, but then the guy calls them 2 or 3 years later. How does he handle that? It's very expensive and it's probably scary for an OEM. If enter the world of universal automation, enter the world where you have a single software package that's out there. You can have an OEM develop a machine that has smart devices on it. He tests it with, say, a soft DPAC. He doesn't have to give that soft DPAC to his customer at all and supply it. He just has it as a test machine on the side. He tests his machine. They're all smart devices. And then he can give it to the customer and say, hey, here's your code. This runs. It's already proven. You can run it wherever you want to run it. You can run it on a PLC device. You can run it on the individual instrumentation devices, whatever, soft PC, whatever you want to run it on, Mr. Customer. He only has to develop the logic and the code and the application once. That's it. And he gets to reuse it. And think about how that frees up the time for an OEM. Now they can spend their money and their energy making their machines better, right? Innovating on their machine of what they're doing. That makes them more profitable. From the end user perspective, it's the same. It's kind of the same thing, except in reverse. I'll take an example of a big oil and gas refinery, and you think about an oil and gas refinery. They may have, like, say, 40 different refineries around the globe. And if you look at the lifespan of an automation system, it's somewhere between 20 and 30 years. So let's say on average, they install systems and they're about 20 years. The math works out easy for me. That means that an oil refinery has to do a major upgrade every 6 months around the globe. Think of the energy, the money, and the risk that goes into having to shut down an oil refinery to do an upgrade of their system, and they have to, redo all the I/O that's out there. The entire control system has to be gutted, and they have to rewrite all that control. When at the end of the day, when they start it up again, they're doing the same thing that they did yesterday, which is, do oil, right? Whatever their business is that they're doing the same exact thing. Yeah, they got some more benefits out of it. They probably get some more information off of it. They probably improve the process, but they're in this cycle of every 20 years having to do a major upgrade, and that costs a lot of money. In this scenario, in this scenario, as products aged in the field, all they would have to do is just replace it with another universal automation device that's out there, and then the software will download to it. Again, disconnecting the hardware from the software has a lot of advantages to an end user. They no longer have a system that would be out of date per se, or aged or obsolete. It's constantly changing, and it's able to constantly change because you're right, there's no direct coupling of the software and the hardware. So again, looking towards, driving towards 100% effectiveness, right? Which is decoupling. This is what we have today, which is a tight coupling of the applications to the PLCs. I can't, even today when I have Control Expert, which is my software, and you can think of, other vendors have the same exact thing. When you program, it only programs our PLCs.
Sure.
Right? In the future, that changes, right? That changes where my software, if you were on my software, you can program my PLC or you can program other people's PLCs. And by the way, we're doing that today. We have a couple of test projects that are out there that we have multiple vendors running EcoStruxure Automation Expert. It's not just the Modicon stuff. So we're not just talking this game and it's vaporware. It's actually happening today.
This is,
and again,
go ahead. No, I was going to say, this is what I like to think of this as when I'm talking to either viewers, listeners, or vendors. Is it's really an Android model. If I create an app for an iPhone, it only works for an iPhone. If I create an app for Android, well, it works on Motorola, Samsung, whoever makes that Android device. And this is very similar to that, I think, and that, it's not a visual app that goes on a smartphone, but we're talking about code that runs on a programmable controller. And I think there's a lot of power to that.
Oh yeah, no, I absolutely agree. In fact, in some of my previous presentations, I actually use that exact analogy. We even talk about like home automation. I went out and I bought some appliances recently, and all these appliances all come connected, right? I can connect them with an app. Why I have to have my refrigerator and my stove and my microwave and dishwasher all connected, I don't know, but it becomes convenient, right? Everyone's got some type of automation in their household today. You buy things and they're just inherently connected, whether you're using it or not. We have a Ring doorbell, right? And that Ring doorbell, connects with the Amazon system, right? And it's their ecosystem that they have. Google's got one, and there are a couple others that are out there that have their own ecosystem. And it's frustrating, right? I'm sure as a user in the home, it's frustrating when you have to make sure that it adheres to whatever system that you have. And then you're now locked into buying stuff in that ecosphere, whatever that is, right? Whether it's the Google sphere that you're in, or whether it's an Amazon sphere that you're in, or an Apple sphere that you're in, you are now stuck with whatever comes out, and innovation comes out with only their stuff.
So is there some type of, with Universal Automation, this organization, do they take it upon themselves, and this may be off topic, I apologize, but do they take it upon themselves to make sure that this ecosystem we're seeing on the right-hand side of the slide, that I'm sure that my product is approved to work on this?
Yeah, that's what the Universal Automation organization does. You can almost think of it like everyone's familiar with ODVA, right?
Yes. Yep.
ODVA is an independent organization. In fact, Schneider Electric used to be the president of ODVA for many years, and a lot of people don't realize that, right? They associate it with a different vendor, but it's an independent organization that creates standards. The same thing with Universal Automation. It's an independent organization that creates a standard of how everyone will, operate and communicate. It actually has a runtime. It's a very light runtime operating system that will run out on the instruments and the devices. And the software is a set of rules, and so anyone can write the software and anyone can write the hardware. And once you become part of that organization, all that stuff is given to you.
Yeah, if there's any newer engineers I probably should spell this out. If there's any newer engineers listening, ODVA, Open Device Vendors Association, they did things like, I believe, like Ethernet IP would be in their bucket, right?
Yes,
Okay.
absolutely.
So just so if there's anybody not familiar with that, um, us older folks, we know, we kind of can tell you the whole story of the evolution of that. But go ahead, Lou. I don't want to go too deep into that.
Yeah, no. It's absolutely great. But in order to do this, in order to open up the factory floor like we're talking about, you need to have standards, right? Even look in your own home. I use this example all the time. Also, we all have a television, right, in our room, in our living rooms. Um, but surprisingly, there's not a camera on that TV. You would think if we were looking at the Jetsons age, right, where you were able to call grandma on the television and everyone's sitting in the living room and talking to each other. Today we do that on our phones and stuff, but you can't do it on the TVs. Well, you can't do it because there's no standard, right? Television manufacturers aren't going to go ahead and start putting this stuff when the software is not standardized, the way of communication is not standardized. Like I have an Android phone myself. My rest of my family has Apples, and I can't FaceTime them. It's frustrating,
Yeah.
right? It's frustrating. And so the world, and it's slowly occurring. So when we talked earlier about you talked about networking. Think about the early days of Ethernet, right? There were many different types of Ethernet that were out there. Um, and it was very frustrating as an automation engineer. You had to realize, okay, wait, is this ArcNet that's out there? Do I have NetBIOS that's out there? What other
Painful.
Ethernet do I have? What's the medium? Is it coax? Is it
Exactly.
is it 10 base T? You had to figure it all out. Today, you talk about it's on Ethernet. It's just for granted, right? Everybody knows that it's TCP/IP, right? It's easy. That IT world has standardized in the way that they do things across all vendors. There are no multiple versions of Ethernet that are out there today. It's the same. In your home life, these home automation guys have also recognized that fact, and they are moving, right? There is a consortium that's being put together and standards that are being put together so that there's one home automation standard that all the devices will communicate to at some point, which is great. Great for the end user. It's great for the manufacturer that's building this stuff. It also fosters innovation on the factory floor, and that's where we're going, right? So we're going, well, that factors innovation at the home, and where we're going is that it allows, when we open these standards up, it allows innovation on the factory floor, so people can, or the companies can, develop things to a certain standard, not many different standards, and innovate. So let me talk about a couple of different things that are very unique. And you had mentioned before about, well, how do you distribute all this control? Well, we introduced something called a cat object model. And what this is, and simply, it's an object. It's an object that has your code, your control code in it, all the properties that are associated with that control code, all the documentation. And by the way, it also has graphics. We've been talking a lot about the control side of EcoStruxure Automation Expert. But EcoStruxure Automation Expert has three components to it. One is the control component, the second is a graphical component, and the third is a historian component. So it's all kind of built in to the product itself. Everyone's very interested in the control side of things, but certainly, as we develop, assets and models, we add the graphical component. You're actually just you're building your HMI, your SCADA system, in the same way you're building your control system. They're all contained. They're all the same. So it's actually pretty unique. So you got these CAT object models, and what's important about those? Well, again, we're driving towards 100% engineering efficiency, getting better, removing the low value engineering tasks. And so by doing that, we have these CAT object models. They link together typically just like we do today with any kind of IO block in our control software. Except that this is not like a digital output that's going from one block to another. This is a pipe. This pipe contains all the information relating to this CAT, everything that's relating to this CAT that goes over to another CAT. So these CATs now can be distributed to different locations. This is how we distribute our control on the factory floor to different devices. So when we look at a single program, will be made up of many different CATs that are here. Now I distribute them to an ATV, to an M251, to an M580, to a third-party device, to a soft DPAC. And because this is a pipe of information, every time I distribute it, the PLC and the control package, right? In our case, it's EcoStruxure Automation Expert. It takes care of the communications for you automatically. You don't have to write any code to distribute this this logic at all. It just happens automatically. And so today this sits in an ATV DPAC, but if I decide, you know what, I want to move this to an M251, or I want to move this logic to a soft DPAC, maybe now I have multiple drives that are out there. That's okay. You just take this logic and now you move it over to an edge compute device, which is a PC that's out in the field, or a soft DPAC that's out in the field. And that's fine. Everything still operates the way it does, but you as a programmer have a chance to move it. And once you move it, it happens automatically. You just pick the device it goes to and it automatically communicates. So one of the other benefits of CATs is you're allowed to write APIs, right? Or write APIs that these CATs communicate to. This happens to be a My Data Analytics module. This is a software module. So today you probably have to, if you have a software, you reach into the PLC via maybe OPC, or you're going into some database and then going down, or you have to write some kind of code. It becomes a little kludgy, right? It becomes a lot of data intensive. But if you had a CAT that already communicates to that device, let's say SAP, for example, or maybe Pi, or some other software model where that CAT already exists, all you got to do is just reuse the CAT. And that CAT will have all the properties. It'll know how to communicate that software. And bam, it is a part of your complete automation system. It's no longer a third-party device. It's actually getting real-time information from the factory floor right up into the software. And now you can easily extend that to build business intelligence dashboards, whether it's dashboards or databases or MES systems. Again, data doesn't have to go through another software package or intermediary device. It goes directly from the factory floor right to the software. So it makes programming actually very, very easy, and very easy to distribute the control. So again, the whole thing is around opening this up to a standard that everyone adheres to, a single standard where everyone is writing code to. It allows you to do object oriented programming, right? So you're creating objects and codes. And by the way, and this is the other thing, we talk about innovation, right? You may have an integrator on the other side of the world that does something really, really neat with creating a piece of code and to do something, whatever that might be. And he now has the ability to go ahead and sell that code, right? He can share it. He can give it away, obviously, but because everyone is on a single platform, and these CATs would be the same in any automation system, he now can create something that's very innovative and sell it to the marketplace. And the marketplace would love to buy that, right? It's like, yeah, you know what? I want to do that. I think of the engineering time it takes to redevelop that. Well, why? I can spend a couple $100 and I can buy that piece of code, and now I can use it. Again, very, very powerful. Distributed intelligence, we're making use of the IIoT, right? This is really, truly smart factory stuff, right? This is the next generation where all your devices are smart to some degree and can communicate with each other. Moving data to the edge. We've been hearing about that, in every form of our life, right? Personal life, work life, about moving stuff to the edge. It's all over commercials and stuff. This is truly it. This is moving control to the edge of our factory floor. Integrating our engineering, again, software, you have your objects, graphically and your control. Hardware abstraction, again, the life cycle is drastically increased, separating the software from the hardware. Single application, right? Third-party integration. We talked about, all about that. Distributing the control, and then obviously data consistency, right? Is being able to reach down into our control system on the factory floor, time-stamping that data right up into our software. No middle software at all. The software is now a part of the system and the factory floor. Truly smart. Smart factory stuff. So that's what I have for you today. I hope that you found that pretty exciting.
Now, if somebody wanted to experience this today, right?
Yes.
What would what product? And I know you mentioned them at the beginning. Maybe we can roll back to that slide, but all right, so I want to try this today. I'm sold on the concept. This is really next gen stuff. What products from? Because you guys make a ton of products. I was up on SC.com and just all the different PLCs you have there. It's amazing, right? All of the different modicons and whatnot. So the specific drives, though, that use the new ecosystem, right? What are we looking at?
So today, this is our offering, and more is coming. So it's again around the drive, two ranges of PLCs, which are distributed control, single rack items, right, to distribute your control all over the place, and then a soft DPAC, which is again a distributed control, could sit on a PC. We can say our PC, and we hope you buy a Schneider Electric industrial PC, but you can run it on any PC.
Now, so if it says DPAC in the name,
that's exactly right. That's okay. Distributed.
Okay, and then the name of the development software.
EcoStruxure Automation Expert.
EcoStruxure Automation Expert, EAE. All right.
EAE.
So, yep. EAE. So that's the difference, because some of, as you showed previously, you have a lot of different software packages today. Some is for the legacy stuff, but that's what we're looking at. That would be what you would program. Now, IEC 61499. I think we're all familiar with 61131.
Yes.
But this is what you're saying is everything that you've talked about is aimed at that 61499. Is that correct?
Yeah, the 61499 introduces the CAT object model and how it distributes the control to the edge. And so that's the basis of it. The universal automation takes it a step further, right? And allows the whole basis around that is a single vendor, single operating system, right? Plug and produce, best in class. That's where that's what drives.
That's where vendors can join in and say, look, we want that official stamp that we're part of this ecosystem. We work. So we join the universal automation. We become part of that organization, like ODVA was for networks, and they can be part of that, ensuring that their products will interact with the other products and officially be supported.
That's exactly right. Like, so again, you mentioned the IEC 1131 software. We're all the PLC vendors are on that standard today, but none of them can talk to each other, right?
Yeah.
So in addition to the 61499, which introduces a lot of different concepts, including, by the way, the IEC 1131 is still a subset of the 61499.
Right.
But the universal automation is the part that allows everyone to be on a single set of rules, right? A single how we develop and how we distribute, and that's the sauce, right? That's the magic that allows things to happen. This is the stuff that's underneath the hood, but the universal automation, if everyone is on that single, everyone's speaking the same language, so to speak, then everything becomes interchangeable.
Excellent.
And that's really where we're heading.
And that's universalautomation.org if you're listening and not viewing. And if you're going to Schneider Electric's website, they have a great short URL, SE, for SchneiderElectric.com, which I love because it's so easy to type in.
Yeah.
And you'd be looking for the DPAC those that we just talked about, those products
Yeah.
there.
Yeah, those are
Um,
distributed process automation controllers, and the DPAC stands for.
Perfect. Well, Lou, anything else you want to cover today in this podcast?
Uh, Not really. I mean, I think I went through it. I think it's fairly clear what our vision is. If somebody wants to get a hold of us and they want a presentation on this, absolutely, we'd love to talk more about it. You can get a hold of me on LinkedIn, or you can email me. It's my email address is fairly straightforward. It's Louis Arone @se.com.
Excellent. Well, I appreciate you coming on the podcast, and I'd love to invite you or somebody on your team back in the future, to who could actually show this in action. When you guys feel like the timing's right to do so. But again, thank you so much for taking time out of your busy schedule and your team for helping put this all together. And I really appreciate you coming on the show.
Thanks, Sean. I really appreciate being here.
Well, I hope you enjoyed that episode, and I want to thank Louis again for taking time out of his busy schedule to bring us all up to speed on Schneider Electric's next generation of automation systems. With that said, if you're watching the video edition of this show, please give us a like and a sub. And if you're listening to the audio-only edition of the podcast, please consider giving us a 5-star review, because that really helps us expand our audience as well as find new vendors to come on the show. Now, if you want to follow me and you optionally can support our show, please visit me over at automation.locals.com. And of course, you'll find all of my training courses over at theautomationschool.com. With that said, I want to thank you all for watching again and wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.